Okay, just a quick recap of Geometry 1.1, points, lines, and planes. So besides being able to name things correctly, if you could think about specific examples like in your room or possibly just anywhere in the world, then that might be something that would help you visualize certain things. So a point, just like a location in space, you draw a point, just like you did in algebra, you graph certain points like coordinate 3, 4, or -1, 8. But a point in geometry, you label with a single capital letter, like point P. This is point P on my paper, or it's actually in a plane. A line, so a line, just like you learned in algebra as well, goes forever in each direction. It's straight. So usually you don't see a straight line because mathematically or geometrically, all lines are straight. I tried to draw that straight. You're going to have to bear with me because I'm still getting used to the stylus. But when you name a line, you name it by 2 points on the line, like points L and M. And when you name it by 2 points on the line, symbolically, you need a little line symbol above it. So that's line LM, or it could also be referred to as line ML. If I have a third point on the line, like point N, and in this case, N is between points L and M, there's a lot of different ways that I can name that line. Line LN, line NM, and keep in mind that if I actually wrote these out, I would need the little line symbol above them. Line LM, I can name it line MN, ML. I can even name it something like, although this is not as common, LNM with a little line symbol above those 3 points. I actually wouldn't name it something like line NLM. Because if you kind of trace those out, you'd be going back and forth between the points on the line, and it makes things a little bit more confusing. Just kind of a side note as well, because you might see things online, like in big ideas like this as well. Besides naming a line with 2 points on the line, like line LM, a line could also be named or labeled by a single lowercase, like italicized or cursive letter. Like this could be referred to, sorry about the writing there, line L. And I just write it like this, line L. So that's another way that you can name a line. And then for a plane, again, if you think about something like in your room or just in real life, I always talk about things in the classroom, and I know you're not in my classroom here, but it's like a table or a desk could be a representation of a plane. A piece of paper, as long as it's not like folded up or whatnot, something flat could be an example of a plane. And if I were to draw a plane, kind of like you saw in, I think it was part 2 of the notes. So this looks like a parallelogram, and it basically is. But what I'm trying to represent here is like something flat, has 2 sides. I just can't show you both sides. And then I have to name a plane, or one way that I can name a plane is by 3 what are called non-collinear points. Or you could also think about them as like contact points on the plane, like X, Y, and Z. And we'll talk a little bit more in a little bit about why they have to be 3 non-collinear points. Again, quick review of non-collinear, they're not all on the same line. So this would be, or could be referred to as plane XYZ. I could also name this plane YXZ, plane ZYX. So it doesn't matter the order that you put each of those points in, plane XYZ. But let's just say, so you know why you can't name a plane by 3 collinear points. So here's my plane. And on part 2, we talked about intersection. Let's just say I have a line in that plane. An example of that is, just think about setting a pencil. A pencil could represent a line, even though a pencil doesn't go forever, but setting a pencil either on the table or on a piece of paper. So that would be the intersection of a line and a plane. And then the line and plane intersection will actually be that line. But let's just say I have 3 points on this line, A, B, and C. This plane actually cannot be labeled plane ABC, because if you label or name something, you have to be talking about that specifically. So if I name this plane ABC, then really there's only one plane that could be ABC. And then I'm going to use like some sticky notes to show you. So here's my sticky note. And then if I put on there a line, hopefully you'll be able to see this similar to what I did up on the screen there. If you could see that, I have my line ABC in that plane. Points A, B, and C are all on the same line. Therefore, they are collinear. But if I tried to name this plane ABC, this sticky note is not the only plane that contains those 3 points or that contains that line. And I mentioned in either part 1 or part 2 of 1.1, just because something's not drawn or because it's physically not there doesn't mean that it doesn't exist. Because here's another plane, if I could line these up correctly, that goes through points A, B, and C. And then I could put this at any angle. There's actually an infinite number of planes, since A, B, C are collinear, that go through these 3 points. That's why when you name a plane, you have to name them by 3 non-collinear points. Just like X, Y, Z here, there's only one plane that contains points X, Y, and Z. I can't make a second plane that contains all 3 of those points. There's an infinite number of planes that contains points X and Y. There's an infinite number of planes that contain X and Z, and there's an infinite number of planes that contain Y and Z, but this plane right here is the only plane that contains X, Y, and Z. I'll actually make another recap, trying to keep these videos short, about intersection.